So there are certain histograms. Let's say there are n histograms. Okay, so you know what histogram is, right? Let's say there is an xy axis. So histograms are like piles. Okay, so let's say this has a height of 6. This has a height of, let's say, 2. I'm going to write it. This has a height of 6. This has a height of 2. Let's say this has a height of 5, and this has a height of 4, and then this again has a height of 5, and then let's say this has a height of 1, and then let's say this again has a height of 6. Let's say this is the case, okay? And width of every histogram is equal. Width of every histogram, width equal. Every width is 1 unit width only, okay? So what you have to do is you have to tell me the maximum area rectangle. You have to tell me the maximum area rectangle in this histogram. So guys, everyone look here. There can be different rectangles in this histogram. For example, one rectangle could be something like this. This is one rectangle, right? By the way, what is the area of this rectangle, whatever I have shaded? Yeah, it will be 7, right? Why will it be 7? Because the height that I have taken is the height of this histogram. This is 1, and there are 1, 2, 3, 4, 5, 6, 7 such histograms. So this is 7 cross 1, which is 7 in area. Similarly, there are many others also, right? There are many other histograms that I can consider. There are many other rectangles that I can consider. What if I consider a rectangle like this? So if I consider this much, can you speak out the area of this much? 8. So there can be multiple rectangles over here which you can envision, and now you have to tell me the maximum area of any rectangle. Okay, what will be the answer in this case? What is the maximum area rectangle that you are able to see in this case? You can take a look over here. What about this rectangle? If I take this rectangle, the height is 4 and there are 3 histograms involved, so it will be 4 into 3, which is 12. And this is the maximum area that you can get. You cannot get area more than this. Yeah, you can try out all other rectangles and you will not get more than this. So what is the way to solve this? Okay guys, so those of you who are able to map it to the previous problem, which was finding next greater or next smaller, can you just type in yes? Those of you who are able to somehow feel that this is a question of next greater or next smaller. Let me ask you one simple question, okay? Everyone look at the board. Let's say you had something like this. Okay. Will you ever want to say that, hey, my maximum area rectangle is this? Will you ever want to consider some rectangle like this? This is nonsense, right? Why? Because if let's say you are very, very rigid guy, you are saying that I want this much of width, then why are you stopping just for this much of height? If there is possibility for you to grow in height keeping the width same, why won't you grow, right? For this particular width, why have you chosen just this much of height? You can choose this much of height also. But this is the maximum height that you can choose for this much of width, right? So if you got this, can I say that whatever will be my answer rectangle, its height will be one of the heights of given set of rectangles? Guys, yes or no? Because I just said this thing, right? That's the reason it was important, because if let's say this was your answer, then why you are settling for this much of answer? Why not go ahead? If let's say instead somebody says that, hey, this is my answer, I would say that, hey, why just this much of answer? Why can't you just go ahead more? Why can't you go till here? This will give you even higher area, right? So I know that the answer rectangle's height will be height of one of the histograms. So can I say that, hey, let me pick histogram one by one, And whenever I pick a histogram, then I fix the height of that histogram as the height of my answer rectangle. Now I'll try to draw a rectangle with the maximum possible width and that fixed height, right? So that is how the strategy is going to look like over here. So what would happen? So let's say you iterated on the histogram heights. So the histogram heights are in an array of size n. So let's say you picked ith histogram. Once you have picked ith histogram, then you fix this height as the height of your rectangle, and then you just see that what is the maximum width that you can obtain. So let's say you consider this much of height. So how far can you go in the right side? So let's say something like this came. So this can be covered here, so you would want to go ahead. Again, this can be covered here, you can go ahead. Now let's say something even of the similar height also came, so you can go ahead. The moment a histogram of just smaller height came, will you want to, so my idea is, will you want to proceed beyond this point? Will you be able to do that? Yes or no? No. And what is this with respect to this? Can I say this is nothing, but this is the next smaller histogram for this histogram? Can I say that? Yes or no? Right? Now, the same thing that started from here in right direction, can it start from here in left direction also? Yes or no? Right? Okay. So in the left of this, let's say there was a histogram with this height, and then there was a histogram with this height. Okay? And then this came. So you can just come till here, right? So let's say this index is j, which is the index of next smaller, and this index is I, which is the index of previous smaller. So can I say that I need to track next smaller histogram? Let's call it next smaller element only. So I need next smaller element and previous smaller element, both, for any histogram. So if you know the next smaller index of any element in the array and previous smaller index of any element in your array, then your job becomes done. Yes or no? So let's say this is j, this is I. Now be careful, do not make mistake. Can you tell me this length in terms of I and j? See, height is fixed, height is h, height is this. Can you tell me this thing in terms of I and j? The width in terms of I and j, how much is that? My question is jth histogram included? Is jth histogram included? No. Is ith histogram included? No. So the moment you write this expression j minus I, it gets rid of I and it considers everything from I plus 1 to j. But now you want to get rid of j also, so you need to do 1 more minus 1. So it will be this into this. Cool. So this way you can solve it very easily. So again, to reiterate, you can create a next smaller element array and previous smaller element array. Can everyone create next smaller element array in order n time? I just did it in the last time. And for previous smaller element, what can you do? For previous smaller element, I can start pushing in the stack from index n minus 1. So I can keep pushing in the stack from the index n minus 1. If you can get next smaller index, can't you get previous smaller index, right? I believe you should be able to get it, right? So you can get both of them in order n, and after you have got both of them in order n, then you can iterate over this. You can iterate over the height of histograms, and whenever you are at ith histogram, you just calculate the value of this expression, and whatever is max of this for all, that will be your overall answer. One question: can it not happen that for histogram, like can it not happen that for a particular histogram there is no next smaller? Can it happen or not? Similarly, can it not happen that for a particular histogram there is no previous smaller, right? So what will you have as the next smaller if there is nothing which is next smaller than that? You store the indices, right? You store the index of the next smaller histogram. You store the index of the previous smaller histogram. So in case there is no next smaller, what will you have in the index as the index of next smaller histogram? Because you are performing this equation, so you can't have this thing as nil. So what would you have it? So n minus 1 is not correct again. The moment you say n minus 1, you mean to say that n minus 1 histogram is strictly smaller than this, which is not the case. So what will you have? Yes. Did you get that? How many of you agree with that? That makes perfect sense. So if next smaller does not exist, it should be n by default, and if previous smaller does not exist, it should be minus 1 by default. Yeah, and this makes a lot of sense because for this, the width will be n, and if you apply that equation j minus I minus 1, then you will get n, which makes a lot of sense. So this is the way you can get your job done. Guys, trust me, do not leave this problem. This is one of the most important problems on stacks based on next later element, and tomorrow when we meet, we will be seeing more problems, okay?